you always go down to the next integer in this case. Notice the sum 6 and 1 is 7. You remember how to reduce the square root of m to the sixth?
Would you do something similar to the first one? You have to find like how many pairs of m, which I believe would be.
You do. There's a little bit of a shortcut though. The square root of m to the sixth is m to the sixth to the 1/2 power. There's really a 2 there. This becomes, when you have an exponent to exponent, you multiply them, m to the 6 over 2, which is m to the third. Basically, you cut it in half.
Okay, so okay, yeah.
Now, the last part here is to pair up the stuff that's outside and then inside the root. So 5m cubed square root of 5m.
Okay. All right.
Now, normally I'd say let's do another one like that, but we have a really limited time today, so we'll just move on to the next question. But it would always be good, and you can always tell me, hey Matthew, I really need another one like that. I guess 3 is kind of like that, so but we'll look at number 2 next here. We'll just go in order. All right. So this is really the square root of 36x to the fourth over the square root of 121.
Okay.
The square root of 121 is 11. That's nice. The one on the top is the square root of 36 times the square root of x to the fourth. Could you try reducing that for us, please?
Yes, I'm just gonna rewrite it and just get it on the same track.
Sure. Yeah. Sometimes I go a little faster, but I'm basically giving you a break to get stuff written down, and let me know if you have any questions, of course.
I don't have very much room on this paper. Okay, so I would first square root of 36, which I know is 6.
Good.
And then for the 4, I would do the same thing that you did in the first one. Go
Exactly.
one integer below, so x to the third under a square root.
X squared. So when the previous problem, it was to the power of 7, it was an odd power. This is an even power. Even powers, you just cut in half.
Oh, okay. Oh, okay, yeah.
Over 11.
All right, so that'll be the final answer.
That is the final answer. So 3 is kind of a combination of the first two. You get part of it works out kind of nicely, part of it doesn't. The way you kind of break it apart is the square root of the top and then the square root of the bottom. Now the bottom does work out nicely. The top does not. The top's going to have stuff kind of inside and outside the root. So I'd like you to try tackling this one on your own, please. And if you have questions, let me know. I'm happy to go through it as well if needed.
All right, I have the bottom. I know. I'm pretty
Okay,
sure I have
bottom is
the bottom part
bottom
is
is
9x cubed. Yeah.
yep, good.
But
So the
then,
part on the top, it's going to have part outside the root and inside the root. So just take your time. It's a lot like number 1. Let me know if you have any questions.
all right, I'm actually gonna grab a piece sheet of paper because I don't know how
Sure.
much.
Yeah, sounds good.
Okay, I know to reduce 8 squared, it would be 2 rad and then 2.
Good.
And
Very
then
good.
I don't really have it down what you explained the first time with the odd.
Sure. So let me show it down here. When it's odd, and really it's because 5 isn't divisible by 2. It ends up being 2 with a remainder of 1. I know you haven't seen in a while, but that is what it is. So you always go down. It's y to the 4th times y to the 1. And then you break apart both of those. The reason you go down to 4, you're actually going down to the nearest number that's divisible by 2.
Okay, yeah,
Because
because you just want to subtract 1 to get it even.
exactly.
All right. Okay, so would it just be 2 rad y?
Y squared.
Oh yeah, that's what I.
Y squared, square root of y. Yes, radical y. That's fine. So now you've got parts that are outside the root and parts that are inside the root. You have to pair them up. I'm going to just bring that down here. So it becomes 2y squared square root of 2y over 9x cubed.
All right. And how come you put that 2 on the outside of it and not?
Which two?
Oh, because
I'm sorry, this one here.
yeah.
So if it's on the outside, it stays on the outside.
Okay.
If it's on the inside, it stays on the inside.
All right. Is there anything that we have gone over so far that I should be writing on that like paper, piece of paper?
Yeah, I'm trying to, so I sometimes write formulas like this, although I don't think they're very useful because I think doing an example, you see that.
Yeah, I know that.
Um,
I know that.
right. Maybe the fact that the square root of y, to the 7th is really y cubed square root of y. That might be worth writing down something, some sort of a reminder. Not necessarily an example problem, but something that will help.
And then should I write that under factoring square is completing the square?
I didn't hear what you just said. I apologize.
On that paper that I have, there's like it's split into 4 sections. It says factoring, square roots, completing the square, and quadratic formula.
You're just a little too far away for me to
Oh,
hear.
I'm
Sorry.
sorry. Okay. Can you hear me now?
Yes.
All right. Yeah. So on my yellow paper that I sent over to you, the one that I'm having for the test, it's split into 4 sections. Factoring is one, square roots, completing the square, and quadratic formula. And then like,
Yeah.
what should I write that under?
I think this goes in the square root part,
Okay, I'm gonna write that in the top.
although it's not, I don't think that's what the intention was when your instructor made this. But
Yeah, I'm like honestly allowed to write anything on here.
okay, yeah, then just make a section. It's not really square roots. It's kind of where you were kind of starting to write the simplifying stuff there in the middle. This is kind of where I would put all that.
Okay. And then for the odd one, I split it in half. I know that. I mean, for the even one.
Even one is just cut in half. So the other thing you might write is that like the square root of x to the 4th is x to the 4th to the 1/2 power, which is x squared. Maybe something like that to help remind you.
Okay, yeah.
It doesn't look like you have any odd roots to kind of further confuse this, but
All right.
question for you, is your exam typically like the practice test?
Yes.
Okay, that's good to know. All right, I'll try to keep that in mind here. We should move on to number 4 here.
All right. Should I try this one before?
Sure, yeah. Will you tell me what you're doing before we get too far into it, though?
Yeah, because I know you're not supposed to, you never want a radical on the bottom. So I'm multiplying the rad 6 by itself to change it just to
Good.
6. And then I'm doing the
Yep.
same thing on the top.
Very good.
So I believe my final answer is 4 rad 6/6.
Almost. You can reduce if you
Oh,
can
yeah, yeah, yeah.
outside.
It
If
would
you,
be 2 rad 6/3, sorry.
right. And that's the kind of stuff that's the difference between an A and a B, little stuff like that.
Yeah,
So keep that in mind here. 5 is the more general one. And this might require a note, or something to go on your note sheet here. You multiply the top and the bottom by what's called the conjugate. You don't need to know that word, you just need to know what it is. The conjugate is the exact same thing, except you change the operator in the middle.
to negative, yeah.
If it's positive, positive goes to negative, negative goes to positive. That's it. And you multiply the top and bottom by the same thing.
What is the conjugate like?
The word refers to the idea that these answers are always paired together with something else that's very similar, but not exactly the same.
Okay,
So the conjugate's kind of this name given to it's a descriptor for these pairs of answers.
okay,
You'll see it again, and then maybe it'll make more sense. But for now, on the top, you just multiply like it's 1, so you're multiplying that in to both of these. If it was like 5, you'd multiply these by 5. But the top becomes square root of 3 minus 2. No big deal there.
wait, I do have one more question. Can you
Sure.
scroll back a little bit? So if
I did. If you
if
could
that
just get a
one,
tiny bit closer, I just can't hear you.
yeah, if that one up there were to be a 5, would that rad 3 become rad
No,
15, or would
no.
it just become 5 rad 3?
Yeah, so here's what you're asking me. 5 times the square root of 3 is 5 times the square root of 3. Now, the square root of 5 times the square root of 3 is the square root of 15.
Okay,
That's the difference between
because
what you
then you can
just,
combine like terms.
well, it's that they're to the same power. Really, 5 is to the power of 1 and 3 is to the power of 1/2. You can multiply them all, and you can always multiply. It's just you may not get anything new. You get
Yeah,
something new. They're not exactly like terms. Like terms would be 2 square root 5 plus 4 square root 5. Those are like terms.
yeah, okay. All right, and then
So on the
I
bottom here, you have to FOIL.
okay, and then I do just want to try and try to take advantage of this like sheet that I'm allowed to use as much as I can, because it's basically like she even wrote on the top chapter 9 cheat sheet. Like I just want to write as
Yeah,
much important information on there.
absolutely. Absolutely. Keep the questions coming. This time is for you to figure out what you need for your test.
All right. I just don't know like important things that'll come up that I'll be thankful that I wrote down on them.
Well, everything you're asking me has been really good. So if there's something that's unclear, you should keep doing what you're doing, which
Okay,
is
I'm
just
gonna
saying, hey, Matthew, I don't get it. You know,
it's
that's okay.
that thing that you have boxed right there. I'm gonna write that.
Okay. This thing below applies to question 6, which we'll be getting to.
I'll try to save as much room as I can. Hold on. All right. So, all right. I'm ready to move on.
All right. So we have to FOIL the bottom. First, outer, inner, last. And that's where kind of this stuff you're asking me in the box matters, because it's square root of 3 times the square root of 3, which is the square root of 9. Then it's the square root of 3 times -2 minus 2 square root of 3. Positive 2 times square root of 3 plus 2 square root of 3.
And those cancel.
I'm sorry.
And then those two end up canceling out.
You're a little too far away. Sometimes it's clear and then it gets real muffled.
All right. So
There it is. Good.
do those two cancel out between the middle?
Yes. Yes, exactly.
All right, I'm gonna write that down as well because I'll remember that. Okay, I'm ready to move on.
All right, so the square root of 9 is
3.
3 minus 4. So the whole bottom, everything on the bottom always becomes a number. Like it never has a root in it. Like you said, the conjugate causes things to cancel. And that's what you're seeing down here in red. So it's the top, the square root of 3 minus 2 over -1. But you can't leave your answer like that. You have to give the negative to both of these. It's not a choice. They both get the negative. So it becomes negative square root of 3 plus 2.
Wait, I'm not exactly sure what you just did.
I'm sorry, I just can't hear you if you want to get a little closer.
I'm not exactly sure what you did with that fraction right there.
Okay, yeah, let me show it in steps here. So
Like,
this
are
becomes,
those just numbers that you made up?
we're dividing each of them by -1.
Okay. Oh, okay, yeah.
Right, so the one on the left, you just move, it's more of a notation thing. You just make it negative. The thing on the right becomes
You just change what it is. If it's positive, it
change.
becomes negative.
Yeah, you change the signs. Yep.
All right, yeah. All right.
I really feel like we should do another one of these. Um, is
Okay.
that okay?
Yes, I agree.
I won't make it too crazy, but let's go 2 over 4 minus square root of 3. So the conjugate is 4 plus the square root of 3.
All right. Then I'll solve that one right now. Ooh. And then on the bottom, do I just have to multiply those?
What did you get on the top, first of all?
I got, oh, I just got, oh shoot, I didn't even simplify the top yet. But I got
That's
8,
okay.
8,
Plus
8 plus 2 rad 6. Or
3.
no, 2 rad 3. 2
Because there's
rad.
really a 1 in front. Yeah, it's good. Okay, now the bottom you have to FOIL. Maybe that's something to write down. That you FOIL it. First, outer, inner, last.
Okay. So on the bottom, is there like I feel like there would be like a shortcut to simplifying that.
Well, there is. So if you want the kind of what it is generally, it's that it's a minus b times a plus b. And this becomes a squared minus b squared. So you square the first thing, 4 squared, minus squaring the second thing.
Okay, so
And so
I
4
would end up,
squared is,
I would end up just being 16 minus 3, right?
yes, which is 13. So it ends up being 8 plus 2 square root 3 over 13. And then you do divide each of these. Like you're not supposed to leave it this way. It's a preference. I'm not sure it's really right, but it is a preference.
And then how come you did that to that 8?
I'm sorry.
That 8 right there to the left? If there's no radical over it, how come you did that to the over the right?
It's a little muffled. I'm sorry.
I'm
Okay, just
actually like super close to my computer. I'm not sure.
yeah. Some people use a headset. I mean, last night was fine. I'm not sure what's different today, but
I was on a cell phone last night. Today I'm on a
ooh,
computer.
okay, could be the difference. Right there is great. Like whatever you just were doing. I know it's a little awkward, but if we go ahead and rephrase your question or give me that one more time.
That 8 on the top of the fraction, and then over to the right you had 2 rad 3.
Yes.
If that 8 right there is not above below a radical, then how come you did that with the 2?
You have to divide each of these by the
Oh,
13. Yeah.
okay.
The operator plus separates it. Yeah. Good
Okay.
question. Good question. And just to be clear over here on that 2 times 4 plus 1 root 3, you're only multiplying the numbers in front,
Okay.
not under the root. The only time you multiply under the root is like we were just doing square root of 3 times square root of 3 becomes square root of 9, which is the 3 here.
Okay. All right, and then I did we already
We
did
should,
number 5, right?
yeah, we should move on to 6 now.
Okay. Yeah.
6
We did
refers to, go ahead.
I'm sorry, I didn't mean to interrupt you.
No, go ahead.
Yeah, we were going over one of these similar to this.
You have to break apart the roots. Okay, so like square root of 6, you're gonna come off to the side. That can't be reduced. It's just the square root of 6. Okay,
Yeah.
but the square root of 24, this can be reduced. 2 and 12, 2 and
2 and
6,
2 and 3.
2
Yeah.
and 3. Pair of 2's come out, so this becomes 2 square root of what's left over. 2
6.
times 3, which is 6. So it's -4 times 2 square root of 6. So if there's a number on the outside, it comes down. And this becomes -8 square root of 6.
Okay. All right.
We still have to manipulate the square root of 20. 2 and 10, 2 and 5 times 2 square root of 5. So plus, bring the 2 down, 2 times square root of 5. That comes from the square root of 20. And then you
Before you
can
move before you move forward, I do have one question.
Yeah.
So the three radical 6 when you simplify. Wait. Hold on. No, back. All right, hold on. And then you know how you did the 24, and then
4
that
times
too. Sometimes
4.
like I don't know exactly when, but sometimes I notice that you're not supposed to combine the two numbers together. If that makes any sense. Like sometimes it can be like 4 minus 3 rad 6, but it doesn't. You don't simplify it to be a 1. Like
We're gonna combine them at the end. Right now, we're just kind of treating them as 3 separate things and then
okay.
combining the results at the end.
All right.
And you reduce the root, which is what we're doing off to the side. This is all reduce root stuff to help you with that.
Okay. All right. And then is it okay if I try doing number 6 on my paper without
Yeah,
looking at?
yeah, of course. No, of course. I'm just gonna
Because,
step away for 30 seconds to grab something. I'll be right back.
uh,
All right, I am back. Do you have any questions?
I'm not- I'm not- Right now, I'm stuck at exactly what you have right below. Yeah,
Perfect.
right there. That's where I'm
You,
stuck.
you can combine those. Those are like terms.
Okay, yeah,
So
because
that's
the
the,
radical 6.
exactly. So it becomes -5 square root of 6 plus 4 square root of 5. That is your final answer. There's nothing more you can do.
Okay. For some reason, to me, that almost just seems like too good to be.
And these aren't, you're going to get one like this. This is a typical problem.
Yeah.
Do you want another one like this?
Yeah.
Okay.
That'd be great. And then before you go over it, can I try to do it myself and then see?
Absolutely. Yeah, absolutely. I'm trying real hard to not do that to you. 3 square root 50. Okay. Why don't you try that one, please?
All right, I'm almost there. Just one moment, please.
No problem. Take your time. It's good that you're doing it on your own. I like that.
Yeah. All right, for my final answer, I got 3 rad 2.
Okay. Let's take a look here. So 18 becomes 3 square root 2 times the 5. Did you have that?
Yes.
So 15 square root 2. Square root of 50 becomes 5 root 2.
Oh, shoot. I made a mistake.
Okay.
Instead of multiplying the 5 and the 3, I added the 5 and the 3.
Got it. So
I'm
this
not sure
becomes
how I'd remember to not make that mistake again in the future.
I mean, doing a few more problems would help. We just don't have time. I mean, if you want to
Okay,
cover
yeah,
everything,
and then
I'm happy to give you another one.
okay. Yeah, I think that was just a stupid error. To be completely honest, I do not think I would make that same error again.
Got it. Got it. It's okay. Don't be too hard on yourself. We're practicing for the exam. The exam
Yeah,
is what matters, not
could I hold on? Okay, I'm gonna. Can I have like 10 more sec or like 15 more seconds just to
yeah. Yeah.
fix my mistake? Okay.
Yep.
Yeah, redo the 50. Okay, so I got 15 rad 2 minus 15 rad 2. So then wouldn't the 15s cancel out and it'll just become radical 2 or
Well, if they
0?
cancel, it's 0 root 2, which is 0.
Yeah, because 0 times radical 2, anything times 0 is just 0.
That's right. That's right. Very good.
Okay.
All right. we should take just like a 4 minute, 5 minute break. Um, so,
Alright.
I think you need it. So let's just resume here. I'm gonna just mute myself, but let's agree to resume here at 2:11. Is that okay?
Yeah, that's perfect.
All right. All right, I'm back. Let me know when you are. Hello, hello. Let me know when you're back.
All right, I'm back.
Okay, fantastic. So we have some options from here. I mean, we can work on as many problems as we can. We can kind of prioritize that reference sheet. Um, what would you like to do? What would be best for you here?
I would like to spend a lot of time on that, or not too much time, but like maybe at least like a third of the time that we have remaining to spend writing down some things on that sheet that will help me on the test.
Okay, so here's what I propose. I'm going to snip in the square root section. I'll snip in each section and we'll do one problem of each type and see what kind of questions might come up
Okay.
first, and then we can go from there. So I mentioned this yesterday, that the square roots is the easiest type to identify. Okay. And number 9 is an example of that. So we'll work through number 9 here, and you can kind of say, okay, these are some things I want to write down. So in terms of identification, typically it's just 1x. Sometimes it's in parentheses, power of 2. You start by taking the square root of both sides.
All right.
Now this is something to write down. It's always plus or minus. You have to write down plus or minus always.
Okay. I'm gonna write that
Always,
down.
always, always. Plus or minus.
Did you just make up? Wait, so what would the formula be if like how would you write the formula if the number 2 and like 1 and 36 weren't there?
There's an X somewhere. Somewhere there's an X, and then there's everything else.
Okay.
And you take a square root of both sides. Now, typically the everything else is a number. Typically the X really is an X. It's really 2x plus 1 or something else. So your goal here, maybe that's what you're asking. Your goal is to isolate whatever that thing is that's being squared.
Okay. And then the part where there's always a plus or minus, does that mean you're always gonna have 2 answers?
Yes, that's the fundamental theorem of college algebra. Fundamental theorem of algebra is that you have 2 answers with quadratics. Sometimes you can take the square root, sometimes you can't. Depends on the problem.
I'm just gonna write down you always have 2 answers.
The most common thing is students don't put plus or minus down.
Okay. Were you wanting me to try solving this one?
I'll just work it out with you. I mean, you can, and you, so from here, the square root undoes the square. So this undoes, becomes just 2x plus 1 on the left.
Yeah,
And then if you can, you reduce the root.
plus or minus 6. Yeah. Okay.
Yeah. So some students see this, and sometimes it's presented this way as like 2 cases. It's really, it's really you set it equal to the positive and you set it equal to the negative.
Okay. Yeah, that's actually how I normally do as well.
And then you do solve each of these.
I just don't really know when to break apart the equation into 2 different ones.
Once the square is gone. Once the square is gone, you set it equal to the positive, equal to the negative.
Okay. So on the first one, I would add or subtract 1 from both sides.
That's right.
I'd do that on both of them.
Yep. It actually is the same set of solvings.
Yeah, and then yeah, divide 2 from both sides. 5/2 you can simplify.
Sometimes you can leave it like this. It depends on what the instructor wants. The more you take math, the more improper fractions will be considered okay.
Yeah, actually, I believe she won't mind. She'll take either of those as correct, like if you simplify it or not.
Okay.
Okay. Yeah,
So
for those,
that's everything for square roots. Like there's nothing more really to say on that.
yeah, just the only thing that will change is the numbers, but the formula will always pretty much be the same.
Yes.
Okay.
So we should move to completing the square. Next.
Yes.
All right, so the next problem that I see that would be good to work on, I'll do 12, and then maybe you can do 11 if we have time here. So we'll look at a problem like 12. All right, so step one is to actually move the constant to the other side of the equation. We were doing that last night.
Yeah. Okay. Yeah. I know that as the first step.
And then you leave a space, a placeholder. We're gonna fill that in eventually.
I'm gonna write that down.
Good.
I'm just gonna write down an example problem, like the same one as this.
Sure, yeah, that's a good idea.
I'm just gonna write down all the steps of it so I remember what to do. And then once you divide the 8,
You're actually dividing -8 by 2, so it becomes x minus
yeah.
4 squared.
Okay, yeah. And then once you square that, isn't one of I'm not sure which box it is, but one of them is automatically going to be negative and be the opposite of what the square root is, or
There,
not the
there,
square root.
it's the same. It's the same. And that's why you show it as a box, and a box to indicate you're putting the same thing. I don't know if you have like brothers or sisters, but it would be like they get 16, you get 16, everyone gets 16. We're sharing same thing on both sides.
All right, and then I'm at the step in the equation where the boxes are blank, and then what should I write down below that to indicate like what's the next step after that? The dividing by 2.
Squared, you're squaring. You divide by 2 to go down, and then you square to go back to the box.
Divided by 2. Hold on. I'm just gonna. Oh, when you divide by 2, you divide the first x and the 8.
No, just -8. You're dividing -8 by 2.
Okay, then how come the x down there isn't? Oh, the square root's on the outside. Okay, now I see it.
Well, it's when you complete the square, what you're actually doing is factoring a perfect square trinomial. So this x minus 4 squared is the perfect square trinomial factored form of this perfect square trinomial up here.
Yeah.
But
I
you
was
don't
just
need to know. You don't need to know right now, but that's what it is. And you bring it becomes x instead of x squared. It's a good question. But the number that goes in here is half.
I just don't really understand why it goes from x squared to x.
Okay, so here's why. I'm gonna just show it off here to the right. When you expand x minus 4 times x minus 4, when you FOIL this, you get x squared minus 4x plus 16. The x squared comes from these two x's. And it's because you're squaring it here that it's reduced.
All right,
I
so
wouldn't take too much. I wouldn't want to know as much why right now as how. And how is it always becomes x. And you always divide this by 2. The
okay,
how
so
and the why we can
I'm
maybe
just trying
do
to
it
write
another
down
time.
I'm just trying to write down the same exact formula. So, all right, so once the boxes are blank, x equals. Okay. All right. I'm ready to move on.
Okay, so on the right side, minus 15 plus 16 is 1. And this is really important now that you see what we have written. This is This is now a square root method problem. Even though we completed the square, like everything we just did up here is completing the square.
Yeah.
Once you complete the square, you then use square root method. So what did we do in the previous problem to solve this?
Put a square root over both.
Square root of both. On the right, though, it's plus or minus. Plus or minus, can't emphasize that enough. And then you have two solutions.
All right. So x minus 4 equals, let's say, +1 for the first one and then -1 for the second one.
You got it?
Add 4 to both sides.
Good.
All right. And then what is the square root of 1? It's just 1. Yeah, right? Just
There's
1.
this one, yeah. That's another thing you might write down, I suppose, is there's all the possible square roots that you might need to know. You know, I don't know, like 1 squared is 1, 2 squared is 4, and then you might pair it up with square root of 1 is 1, square root of 4 is 2, but maybe start it down further that you don't know. I don't know, maybe you know like 7 squared is 49, square root of 49 is 7. Not
Yeah.
sure. Okay. If you want, you could try number 11, or we can move on to quadratic formula. I think we should move on to quadratic formula just because of the time constraints, but
I think we should move on to quadratic formula as well, but if we have time at the end, then maybe.
sure. Sure. Okay. 16 is a quadratic formula problem. So the first requirement for quadratic formula is that everything on one side. You really have to get everything on one side of the equation. So that means you're going to subtract 9 from both sides. X squared plus 2x minus 9 equals 0.
All right. I'm just gonna write that down. Everything on one side.
Yeah, the second thing is you really want everything in descending order. And that's the standard form, ax squared plus bx plus c. That's the fact that, okay, it's x squared first, then x, then the constant.
Is getting everything on one side always the first?
Yeah, typically, yeah. I don't think there's any exceptions to that.
All right. Okay, this is number 16. All right, I'm gonna write down the same thing. X squared plus 2. All right. I'm at the same spot as you now.
Okay, so the next thing is to identify a, b, and c.
Is the second step?
Well, you need those values in the formula. So a is the number in front of x squared. B is the number in front of x, including the operator. C is the constant.
C is always the constant.
C is the constant.
Okay.
Ax squared plus bx plus c. You have numbers for a, b, and c. They go in front. If there's nothing written, it's a 1. 2x minus 9.
Yeah, if you don't mind, I'm just gonna write down what you have in the blue, the ax squared plus
Yep.
bx.
Yep.
So then it's obviously A is A, B is B, and C is C.
Yes.
And then once you subtract 9 from both sides, the 9 always comes right before the equal sign, right?
Well, it's whatever. I mean, you could get a problem where the 2x is on the other side and you have to move it over. So the descending order tells you that x squared comes before x comes before c.
Because whatever you subtract from the right side is always going to be like.
You want it in descending order, meaning highest degree power first, then the not the power of 1, then no powers of x.
Okay. Alright. All right, and then I'm ready to move on.
Okay. Next thing is the quadratic formula. So we're going to write that down. Minus b plus or minus the square root b squared minus 4ac all over 2a. Now I showed this to you yesterday and I said, hey, I like to show it where you're substituting the variables in parentheses.
Okay.
That'll be really important here coming up.
Coming up like.
Meaning we're going to evaluate this. So you're going to see why that's important in a moment.
Okay. This can be the same exact formula of all the variables.
Yeah, go ahead and get this down.
So that B, you don't put the negative in the parentheses, you just put the B in
No,
it.
just the b. Because the b value could be negative, and then you have to make sure you negate the negative. So whatever b is, you put it in parentheses. Whatever c is, you put it in parentheses. You don't try to manipulate signs outside of that.
Oh, I forgot that it's over 2.
Okay, so the next thing here is to put the numbers in. If you could just try that, saying that one more time.
I'm just gonna write down real quick, thinking like.
Okay.
Okay, and I'm ready to move on.
All right, so we're going to put the numbers in. It's minus parentheses 2 plus or minus square root 2 in parentheses squared minus 4 times 1 times -9 all over 2 times 1.
And the plus or minus always indicates that you need to make 2 separate equations, right?
Yes, you'll do that at the end, but yes, that's correct.
All right. So once you simplify what's under the square root, then you do that at the end.
Yeah, most of the issues come from simplifying what's under the square root. So that's what I want to look at with you next here. 2 squared is 4.
I'm sorry if I'm asking too many questions. I'm
No,
just trying
please. Please, these should, I mean, I'm going to say it this way, these should have been answered by your instructor, but clearly they've not been. So please ask, these are questions you would ask, right away when you see this stuff and you
Yeah.
just didn't get your answers. So yes, please ask, keep asking.
All right. All right, and then I'm on the same track as you now.
All right, so 2 squared is 4. I'm going to kind of write that over here. 4 times 1 times -9 is -36. So it becomes minus a -36.
I wouldn't have been able to do that in such a small amount of steps as you did on the thing.
Okay, yeah, and to do it however you would normally do it, but the net result is you have to be able to get the signs right. You have to say, okay, this is really, it really ends up being 4 plus 36, which is 40.
You meant 39, I believe. Oh,
Take another look. Yep,
no,
take one more look.
I
I do
had
make mistakes. I do make mistakes. Don't. It's okay to correct me. Um, so
yeah,
pretty sure though that is
I
40.
Okay. Never mind, I was wrong.
All right, so that what we did on the right here represents everything that's under the square root. Okay, so it's square root of 40. Then we're just filling in the other pieces. So it's -2. 2 times 1 on the bottom is 2.
All right. I'm just gonna get on the same track as you. All right, and then I'm sure you could obviously simplify the 40.
Yeah,
So
why don't you simplify that, and then we'll talk about what to do from there.
it would be 2 rad 10.
Okay, so it becomes -2 plus or minus 2 square root of 10 rad 10. And then from earlier, rewriting that part from earlier, you know to divide each of these by the bottom.
Yeah.
-2 over 2 plus or minus 2 square root of 10 over 2. Notice on the right, I'm showing it over the front number because that's the only one you can divide. You can't divide inside the radical.
All right. Yeah. I'm running out of room on my quadratic formula box. So I'm trying to cram it in without it being too unorganized. All right, so 2 plus
You,
or minus. I need to like also engrave that in my head, like the plus or minus thing. I really do not want to make this on the test. And then when you divided both of them by 2, how? Okay, wait, never mind. I thought you were dividing. Okay, never mind. Forget what I just said.
it's they both get it. It's not a choice. You have to do it for both.
Yeah, I know. I thought you were doing it because of that -2, and I was curious why it was positive and not negative. But I realized it was like part of the.
Yep. So 2 over 2 is 1 or -1. You include the sign. Then 2 over 2 on the right is 1. So it becomes square root of 10. And that is your final answer.
2 divided -2. Okay, yeah. It would be. And then how would you get the 2 separate answers? Would it just be x equals 1 minus rad 10 and x equals 1 plus rad 10? So those.
But it's -1. So yeah, yes. The answer to your question,
Yeah.
yes, but it's -1. -1 plus square root of 10, comma, -1 minus square root of 10.
Okay.
And notice these are conjugates. We talked about that earlier.
Yeah.
The only difference is the operator between them.
Okay. Yeah.
All right. We're gonna move on here. You got all that down?
Yeah.
Okay, so I'm going to rewrite the quadratic formula, and I'll explain why in a moment here. You don't have to write this down. All right, so there's a part under the square root. This part under the square root, b squared minus 4ac is what's called the discriminant.
Okay.
I'm gonna just check the spelling. I mean, I don't really emphasize that, but your teacher did not.
It's all good if you don't spell it correct.
Your teacher called it the discriminate, which what it is. That's okay.
Yeah,
The
I'm
word's
sure she had a
word's
misspell.
not super important. Okay, so there are three possibilities for the discriminant. And I don't know where to tell you to put this, maybe under the completing the square, but this is notes. This is stuff you'll want on your test. If the discriminant is greater than 0, meaning it's positive, it has two real solutions.
Okay, so you want me to write that under completing the square?
Well, it really is under square root, but you don't have any room for that. So I'm just suggesting maybe to open up some other space on your page.
Did you mean under quadratic formula?
It would go under quadratic formula, but you were saying you were running out of space.
Okay, yeah, so I'm just gonna go ahead and write that in under completing the square. I'm just gonna actually like extend my quadratic formula box over.
Good. That's good.
All right. All right, so can you scroll up just a very tiny
Sure.
bit?
Yeah, I was just reframing the problem with the quadratic formula.
Yeah, I'm gonna rewrite the formula and then circle that and say that's the discriminant. Wait, so what exactly like is the discriminant by definition? I don't mean to like, I just want to make sure I
It's
understand.
so by numbers, it's the part that's under the root. But what it actually is it tells you the type and number of solutions. The type and the number of solutions. It's a way to know something without doing the entire calculation. For example, like it's like knowing that it's hot out, but not knowing how hot it is.
Yeah. And then,
We can
okay, and
make
then can you repeat that like quote that you said to me like a minute ago? If the discriminant is greater than
if it's greater than
0.
0, if it's positive, if the number you get for b squared minus 4ac is positive, then there are two real solutions.
Okay.
And that's actually what we had in the last problem. We had two real solutions. Real refers to the domain of the space that we're solving the problem in, which that's the kind of this macro view that you don't need to know about. But if you're a math guy, if you like math, you should know that you're in the real domain solving these problems.
Yeah, and then if the discriminant is negative, then it is no solution, right?
So there's three cases. The next one is it equals 0. You just mentioned the third one, negative. That means there are no real solutions. And you'll learn probably next year, because you're probably done with your class, that there are actually solutions. They're just not in the real domain.
Yeah, I think I'm doing geometry next year.
Okay, so it'd be the year after.
Yeah.
All right. If it's equal to 0, completely equal to 0, and that does happen, it's one real solution, but it's what's called repeated, meaning it's the same.
If the discriminant is less than 0, then no. Okay.
All right, so we have time to do 17, maybe 18. You'll
And then
notice in
also
set.
for number 7 and 8, um,
I'm sorry, I
I'm not
didn't quite understand.
I'm not exactly sure how to do number in 7 and 8, the graphing ones.
Okay, yeah, we'll try. We'll do this one, and then we'll go look at one of those.
Okay.
Okay. To do the discriminant, you have to get everything on one side of the equation, which is the case here. If you look at 18, you'll notice 18 does not have everything on one side of the equation. Right, if you just look at those side by side on your paper there on my screen, like 18 doesn't have everything on one side, so you have to move stuff. But we're doing 17. Okay, so don't worry about that for the moment. You have to identify A, B, and C.
Yeah, and then should I write that under factoring, square roots, quadratic formula, or completing the square?
This again, this is all quadratic formula, but you're welcome to put it wherever you have room. I mean, you mentioned having more room under completing the square.
Is quadratic formula considered like
This is part of the quadratic formula.
oh, first up?
Let me know when you get the values of A, B, and C, please.
Okay, A is 4, B is 4, and C is 1.
So you have to know that the discriminant is B squared minus 4AC. It's that part under the square root. And again, probably good to show the letters in parentheses.
Okay, and then that's how I write my formula. D equals B squared minus 4AC.
Yes. And then we will substitute the numbers in.
All right. I'm at the same spot as you now.
Okay, so you have to be able to calculate this. You mentioned that you might need a bit more steps to do it, but think about the right here. It's 4 times 4 times 1. What would that become?
Negative 4 times negative 4, so negative
No,
16.
no,
I mean, negative 4 times positive 4, so negative 16.
okay, and that's fine. Yeah, that's totally fine. Then the 4 squared is 16. So this becomes 0. The discriminant is 0.
Real solution.
There's one solution. That's the middle case here.
All right. I had that written down as well, so I won't forget that.
Okay, now to actually find the solutions, you have to continue with the quadratic formula.
Okay.
So we can do that here if you'd like. X equals minus B plus or minus the square root squared minus 4AC all over 2A.
Is that in order to find the solutions?
Yes. But keep in mind, you've already done the part under the root. The part under the root is 0.
Instead of writing it all out, I'm just going to point an arrow next to the 0 to say, to find the solutions. All right.
You have to substitute the value in for B, substitute the value in for A. We know that the part under the root is 0. Let me know when you get caught up.
Oh, is the reason that there's only one solution is because the positive and negative is always going to be 0, so it doesn't matter. It's just going to be one thing.
Exactly. Yes.
Okay. But if that was 1, then it would be like a positive 1 and a negative 1.
That's right. That's right. So it just becomes minus 4 over 8. And the plus 0 minus 0, you just exclude.
And then you can simplify that to negative 1/2.
Yes.
think I'm pretty good on those ones. Is there anything you think that would be important for me to write in the factoring box?
I mean, there's a whole, like, basically the first two. I mean, I don't want to say this. There's like 5 different types of factoring. We don't really have time to cover them all, but there's a few examples we can do real quick if you would like.
All right. I don't need to. I don't think we need to get into all of that due to the fact that we only have like 3 minutes left.
Yeah,
But
we're actually gonna stop about 2:55, maybe 50. I have to take a break between lessons, and they're normally only 50 minutes anyway, so I'm trying my best to give you the most time I can, but
okay,
we probably really don't have time to do like one more thing. So either the graphing thing or some factoring.
I think the
If
graphing would be important.
okay.
I just don't know where I should write that information under. I'll just write it under the factoring box because I have a lot of.
You kind of are going to factor here. This is not a well-written question, so it's one of those where I wish you're. So I don't want to say this. One approach here is to graph x squared and then to graph 6x minus 9. And we'll do it better, but these are lines, so they end up hitting. One's a quadratic, one's a line. Don't think that's what the instructor wants because it says factors down here. I think what they want you to do is first move stuff over. I apologize for being vague. This is me just trying to interpret what your teacher wants.
Yeah. All right.
And then you add 9, so you end up getting x squared minus 6x plus 9 equals 0.
Okay. And then just move on from there. I just don't really know how to put on the graph. I'm not exactly sure what to do after like right here.
Yeah, so you either need to put it in vertex form or find the vertex or factor. I would probably find the vertex. That's probably the most robust way. That'll work for a lot of problems.
So would that be step one? Like step one would be get everything on one side, and then step two would be like find the vertex.
Yes. Yeah. So there's some formulas for finding the vertex. So let's do that. You would again have to find A, B, and C for that.
Okay.
There's a
Okay.
lot of overlap once you get to the end of this where you say, okay,
All right. So step one, get everything on one side. Step two, find the vertex. And then in order to find the vertex, first thing you need to do is
so the value of A is 1, B is -6, C is 9.
yeah.
And so there's a formula here. The X coordinate of the vertex is minus B over 2A.
Yeah, I know that. That's the axis of symmetry.
It is also the axis of symmetry, yes. So it becomes -6 over 2 times 1. To find the y coordinate of the vertex, you put the x value back in.
Okay, so is there like a formula for it?
Whatever you're given. So in
Oh,
this case, you're given x squared minus 6x plus 9. You're going to put that back in. So you're going to have 3 squared minus 6 times
so that you
3.
just plug in the axis of symmetry.
Yes. This ends up being 9 minus 18 plus 9. It ends up being 0.
Okay.
So the first point you have to graph is vertex, which in this problem is 3, 0.
And then I believe from there you go like up 1/1, like up 1/3, then up 1/5.
That only, it's 4 for the next one. Or I'm sorry, 5, yeah, 5 if you're going from the original. That only works because there's a 1 here in front.
Yeah, but if it was a 3, then you'd go like up 1/3. Not exactly sure how it works.
It's not that simple, but it'll work for this test. I'll just say that. The better way to do it is to then create a quick table based on the vertex,
All right.
and you choose 2 smaller values and 2 larger values.
And that is to,
You typically want 5 points, like you were mentioning. You go right 2 points, left 2 points to get it. Now, because of symmetry, you don't have to actually do all of these. You just have to do some. So like you said, this ends up being 1 and 1. If you put like 2 in for X, 4 in for X, you get 1 and 1 there. So you get some new points to graph. And then for 5 and 1, you end up getting 4 and 4. And that's what they're looking for. They're looking for 5 good points, typically. Any chance you're allowed to use a calculator on this test?
yes, we are.
Oh, so you could graph it. I mean, you could literally graph this and make sure it's in sync with what you're expecting.
Yeah, but I'm in Algebra 1, so we're not using graphing calculator.
Okay, okay, I should have clarified. Yes, if you're
Yeah.
using a graphing calculator, but you're not, so unfortunately, no.
Yeah. All right. I think that was very helpful, actually.
Okay, we got like 2 minutes left here. Any other quick questions, thoughts?
Is there anything you could think of that's very important that I should have written down on this paper by chance?
Yeah, you mentioned the factoring box. I would pick some problems from, let me just snip in the ones that I would put in. So I would learn how to factor like these first 2. Let me snip this in. I would maybe show examples of these 2. And then let's see if you got this other one. Like this one on the right's a GCF, the one on the left's just an A equals 1. We did one like this last night. This one here. This one was pretty tough because we had to use grouping. Maybe a couple of those might be worth putting in
All right.
as examples.
Okay. Other than that, I think I'm all set.
All right, I'm gonna go and just stop right here.